Now let's take a look at some examples. We have sample data, we have some questions that are provided, we want to construct confidence intervals and then interpret those results. In example 1, we have a study that compared various therapies for teenage girls suffering from anorexia. Each girl was weighed before and after the treatment. Therapies were designed to aid weight gain corresponding to positive X values. So in this case, these numbers are telling us about their change in weight. So a 0 would mean the program was unsuccessful, they didn't gain or lose any weight. A negative value would mean the program was unsuccessful, they actually lost more weight as a result of being in the program, when the goal of this was to get them up to healthier weights, help them eat healthier and gain weight. So wherever we see positive values, we're getting successes. We want to construct a 99% confidence interval for the population mean, or actually we should probably update that and say population average. Can we conclude that this treatment is effective? So effective, again, meaning we're getting positive values. So the first thing we need to do is determine whether or not we can estimate the mean. Our sample size is 17, so our sample size is too small. So we need to construct a QQ plot, add the correlation statistic, which in this case is 0.974, and then generate that critical value. So for a sample size of 17, the critical value for our QQ plot is going to be 0.9437. So we can say the correlation or the QQ plot has a correlation statistic of 0.974, which is greater than 0.943746, which is the critical value for the QQ plot. That means this sample data comes from a normal population, and we can estimate the mean. So since we can estimate the population mean, we can actually answer the question the way it was written. We want to come up with that 99% confidence interval for the population mean. So to do that, we'll go back to StatCrunch, and we'll select Stat, T-stats. So again, we're using that T distribution, since our population standard deviation is unknown, one sample, and with data. So we select our variable, and then in this case, we want a 99% confidence interval. And we get our lower limit and our upper limit. So we can say the 99% confidence interval estimate for mu, that population mean, is 2.2057 to 12.3825. So can we conclude this treatment is effective? So a value of 0 or a negative value would be ineffective. Anything positive would mean weight gain. So yes, we can conclude this treatment was effective. Because all values in the confidence interval are positive. Meaning, on average, participants gained weight. So it'll vary each time with these intervals what we're looking for. In this case, we had to pay attention to the problem. We wanted to make sure our confidence interval ended up with all positive values. If 0 was in the interval, then it would be likely that an average person had no weight gain. If all values were negative, it would mean on average people actually lost weight, so became less healthy as a part of this treatment. So in this case, this sample data suggests that this program is successful. In example 2, we have the estimated number of non-occupational fireworks related injuries that were treated in U.S. hospital emergency departments by different years. We want a 95% confidence interval estimate for the number of people injured in non-occupational fireworks related injuries each year. Again, our sample size is too small. We have less than 25 data values. So we'll construct a QQ plot with the critical value, or I'm sorry, with the correlation statistic. And then we'll calculate our critical value. So we have a correlation of 0.941. We'll calculate the critical value, which in this case is 0.917. So our QQ plot has a correlation statistic of 0.941, which is greater than 0.917895, which is the critical value for the QQ plot. This means our sample data comes from a normal population, and we can estimate the population mean. So the conditions are met to estimate a mean, and the 95% confidence interval estimate if we flip back to StatCrunch, we'll again select Stat, T-stats, one sample, and with data. Select variable 1, and our confidence interval is already, our confidence level is already set to 95%. Click compute. So we get our lower and upper limit. So our 95% confidence interval estimate for the population mean, mu, is 8,444.85 to 9,855.15. So in this question, we're not being asked to interpret anything. We're not being asked to answer any specific question. But we could say this interval contains the likely values for the average number of people who are injured in these non-occupational fireworks related injuries each year. So again, that process of verifying the conditions, making sure we're able to estimate the mean first. In example 3, we have information on the number of points the Bears scored in their 2012 regular season games. We want to construct a 90% confidence interval estimate for mu, or really in this case we want to estimate the average. So we first want to make sure that we can estimate the mean. Packers fans are predicting that the Bears will average at most 2 touchdowns, so 14 points per game this season. Does this data support their prediction? So our first step is to see if we can estimate the mean. Since our sample size is too small, less than 25, we'll construct a QQ plot with the correlation statistic. In this case, we get a value of 0.978. Our critical value is 0.941. So since our correlation statistic is larger, the conditions are met. So our QQ plot has a correlation statistic of 0.978, which is greater than 0.941138, which is the critical value. For the QQ plot. This means our data comes from a normally distributed population. And we can estimate the mean. So we want a 90% confidence interval estimate. So using T-stats, one sample with data, we'll set our confidence level to 0.9 to generate that lower and upper limit, and then interpret our results. So the 90% confidence interval estimate for the population mean mu is 17.62 to 29.25. So Packers fans are predicting that the Bears will average at most 2 touchdowns per game this season. Does this data support their predictions? So the prediction is not supported since all values in our confidence interval are greater than 14. This means, according to our data, the Bears will average more than 14 points per game. So in this case, their estimate was too low. We've got values from a little over 17, so about 18 up to 29. So we have a higher range of values for that average, all values above 14.